Hi, welcome to Math Antics. In this lesson, we're going to learn what proportions are and how we can use them to find an unknown value. The good news is, if you know about equivalent fractions, then you already know a lot about proportions. To see what I mean, let's start with the simple fraction 1 over 2, or 1/2. Now let's look at a pair of equivalent fractions, 1 over 2 and 5 over 10. These fractions are equivalent because even though they have different top and bottom numbers, they have the same value. 1 is half of 2, and 5 is half of 10, so they represent the same amount. Okay, but to understand what a proportion is, we need to start with a ratio instead. A ratio is basically just a fraction that's used in a certain way. If you don't remember what a ratio is, you can watch our video about them. So let's imagine that a student who's a really good reader can read one book in 2 days. We could say that the ratio of books to days is 1 over 2. One book per 2 days. Alright, but what if our student reads books at that same rate for 10 days? How many books would they read? Well, if they finish one book every 2 days, then in 10 days they'll have read 5 books. So that ratio would be 5 books per 10 days. Do you see what we have here? These are equivalent ratios. Just like the equivalent fractions, they represent the same amount, so we can put an equal sign between them. When we do that, we have a proportion. A proportion is just two ratios that are equivalent or equal. And one thing that's really important to remember. In order for two ratios to be equivalent, they not only have to have the same value, they also have to have the same units. That is, they have to be representing the same thing on top and on bottom. Let me show you what I mean. This is a proportion because the top numbers both refer to books and the bottom numbers both refer to days. But what if we change the top unit of the second ratio to be pizzas instead of books? 5 pizzas in 10 days is not equivalent to 1 book in 2 days. So even though the numbers are still the same, this is no longer a proportion. Or what if we keep the same units and just switch them in the second ratio so that the days are on top and books are on the bottom? Are they still equivalent? Nope. This is not a proportion anymore either. 5 days per 10 books is not equivalent to 1 book per 2 days. So the units have to be exactly the same for both ratios to form a proportion. Alright then, so a proportion is a pair of equivalent ratios. But why do we care? What are proportions good for? Well, it turns out that proportions are really good for figuring out something you don't know from something you do know, and that makes them very useful. For example, let's suppose that our student, who's a good reader, has a big stack of books that they want to read. 23 books to be precise. And they want to know how many days it will take them to finish. How do we figure that out? Well, let's start with what we do know. We know that they can read 1 book in 2 days, so let's take that ratio and set up an equivalent ratio for 23 books. The key in setting up that equivalent ratio is to make sure that the units are the same as the first ratio, books on the top and days on the bottom. We know that the number of books that they want to read is 23, so that goes on top. But the number of days it will take is unknown. So instead of putting a number there, we're going to put the letter in there temporarily to stand for the number that we don't know. This is how you'll usually see and use proportions in math. 3 of the proportions numbers will be known, and 1 will be unknown. Fortunately, if you know 3 of the numbers, you can find the missing number easily using a procedure called.
Thanks, Mr. Math Antics. 6th graders, we are now going to get back into our notes, so we're going to be on the second chunk titled Solving Proportions. And we today are only going to take a look at 2 strategies that I've given you. I know there are a total of 3, but we're going to look at 2 of them. So let's get back into our notes right now. Multiply or divide the numerator and denominator of the given ratio by a factor. When I say the given ratio, that is the ratio where you have both the numerator and the denominator. Sometimes strategy 1 doesn't work, so we have strategy 2, which says simplify the given ratio and then follow the same idea given in strategy 1. We're going to go ahead and do an example of each one of these strategies. As I mentioned before, I realize there is a third strategy on your note sheet, and we're going to talk at a later time about that strategy. Let's go ahead and get working on the first example in our notes. So we have a proportion set in front of us that needs to be solved. There's a part of one of the ratios missing. So we have 35 to 7 is the same as something, so I could put a question mark there, is to 21. Both of these ratios need to represent the same value. And since I don't have labels, I'm going to assume that the labels are aligned. My job now is to just figure out this unknown part. And sixth graders, sometimes in math, you'll see unknown as question marks, but other times you'll see unknowns written with a variable. I'm going to go ahead and I'm going to pick a variable. A variable is just a letter in math. So I'm going to pick X right now. We'll say X is my letter and it is the unknown. So now, do you see how you could be going from one ratio, the given ratio, to the other? Yeah, so we get to use strategy 1, where it says multiply or divide the given ratio's numerator and denominator by a factor to solve the proportion. I can see how I'm going from 7 to 21. I'm going to be going up, and I'm going to be going up by what? I'm going to be going up by 3, so I'm going to be multiplying by 3. I need to do the exact same thing on the top. Go up proportionally by 3. So 35 times 3, I'm going to have to do a little math off to the side. 9, 15, I get 105. So that means my X value, I can write this as X is equal to 105. And again, I don't know what the labels are. I can make a fair assumption. That means I can say that this label is going to be the same as this label, and this label is going to be the same as this label. So when I solved this proportion, I got to use strategy 1, which my mind is going, hey, this is just like solving equivalent fractions. And that is so very, very true. Let's go ahead and let's look at an example of strategy 2. Make sure, though, before we move on, that you have all of this information neatly written in your notes. For our second example, we have something. That letter is representing my unknown. It's what I have to find. Is to 27 as 7 is to 21. Now, in strategy 1, we could see how we were going. Given the known ratio, we could see how we were going from one ratio to the other. And then we could go up or down proportionally. We could either multiply or divide. But now I don't see exactly how I'm going from 21 to 27. This means I need to go to strategy 2. Can I simplify the given ratio? Can I simplify? This is my given ratio because I have the numerator and the denominator. Does the numerator and denominator share a factor besides 1? Yeah, so that means I get to apply strategy 2. What can I divide both the numerator and denominator by? I can divide it by 7. So now I have 1 is to 3 as something is to 27. Now, starting with my known ratio, 7 to 21 is the same value as 1 to 3. I simplified it. Do I see how I'm going from this ratio to this ratio? You bet I do. I am multiplying by 9. So I'm going to take my top value and multiply by 9. 1 times 9 would be 9. So that means my unknown value is 9. I could put 9 in here and I would read it as 9 is to 27 as 1 is to 3. These two ratios form a proportion because they represent the same value. Since I don't have labels with these numbers, I have to make the fair assumption that this label would be the exact same as this label. This label would be the exact same as this label. When it comes to the back of your notes, ladies and gentlemen, we are going to do that at a later time. So as of right now, your notes are done when it comes to solving proportions. Make sure you have all of this, for example of strategy 2, in your notes and that it's neat and clear so that you can use that as an example.
Where are you going? We're gonna miss the play!
When the McAllister family left on their Christmas vacation,
Did we miss the play? No, you just made it.
they forgot one small thing.
Have yourself
Terrible feeling. Did you lock up?
let yourself be light.
Do we set the timers on the lights?
What else could we be forgetting?
Our troubles will be out.
Kevin!